Hello students, in this video we are going to learn about Bernoulli trials and binomial distribution. Okay. Now, this chapter is very simple because in the random variable when we were doing problems, some of the problems were based on binomial distribution and we unknowingly used it, but now we will learn binomial distribution and then we will use them. Okay. Now, the main important thing in binomial distribution is whenever you do an experiment, there are outcomes, but now we are going to consider them as two outcomes. For example, if I throw a die and getting a prime number is a success means not getting a prime number is a failure. So we just relate it like that. Suppose you have cards in which numbers 1 to 20 is written. Picking an even number is success means not picking an even number is not success. That's all. Okay. So there are only two outcomes. One is success, one is failure. So that is the first rule. Okay. One is success and one is failure. But when you are doing the experiment many times, suppose I am tossing a coin, suppose I am tossing it 100 times, every time the events are independent of each other. The trials should be independent. Like first time I throw a coin, I get a head or tail. Second time again I throw, it is not going to affect what is going to be the outcome because it is independent in nature. Okay, so each trial is independent. For example, if you have a box of balls, some are red balls and some are white balls. If you take out a ball in the first trial and then find out whether it is red or black, if it has to be a binomial distribution, then the ball should be replaced in the bag again. If it is not replaced, then it cannot be a Bernoulli trial because the ball you took out in the first choice, first time, will affect the second ball which you are drawing if you are not going to replace the balls. Okay, so very important, the trials should be independent. Independent means whatever was the initial condition in the experiment, same should prevail in all the experiments. Okay, and I'm saying we are going to toss the coin 50 times, 100 times, and something like that. Okay, so it should be finite number of trials. Like I cannot throw a coin infinite number of times. That you will study later in Poisson distribution and normal distribution when you study in higher classes. Right now, the number of trials should be finite. Like it can be 100, even 1000, 5000 and all is fine, but it should be a finite trial. And the last condition is the probability of success remains the same. So what is the probability of success? You know, when you throw a die, probability of success is same in all the experiments. Okay, suppose when you throw a die, getting a head is half all the times. 1000 times you throw, also probability of getting a head is half. Same way when you throw a die, probability of getting an even number is 3 by 6, which is 1 by 2 for all the trials. So probability of success should be same. So that the problem will come only when you throw a ball or when you draw a ball. Okay, so when you draw a ball, the ball should be replaced back in the bag so that the probability of success remains the same. So whenever you read a problem, just to check these four things are there. One is each trial is independent of each other, and the success, there are only two outcomes, success and failure. That is very simple. Getting an odd number is success means getting an even number is failure. That's all. You need not even say even number. Getting an odd number is success means not getting an odd number is a failure. Same way, getting a red ball is a success means not getting a red ball is a failure. That's all. Because P and the success and failure together will give the probability of success and probability of failure will give you the answer 1 because it is the total probability. Okay, now so these are the four conditions you must check. It is either success or failure, and the trials are independent means for each trial is different is same on its own. Okay, and the next one is the number of trials should be finite and the probability of success is same. Because the trials are independent and the same condition prevail, the probability of success is same there also. Okay, so if these four conditions come, we use Bernoulli trials. You remember probability sorry, binomial theorem which you studied in small classes, where we know n of x equal to r is given by ncr p to the power of r q to the power of n minus r. So each term in a binomial distribution or binomial theorem gives you the probability of the event. So r is what? Number of success. If I throw a coin, if I throw a die 100 times and getting a 5 is a success and I want 6 success, means r becomes 6. Okay, n is number of trials and p is probability of success. Q is probability of failure. Sorry, success. Q is probability of failure. And you know clearly P plus Q is equal to 1. Or whenever I want to calculate P, Q, once I know the value of P, I just have to subtract it from 1 and get the answer. So this is the basic concept of binomial theorem. You have to see that the four conditions are satisfied, and it is each term of a binomial theorem gives you the probability for the success. Okay, so r can be 0 also, means you getting an odd number is a success, and you don't even get odd number even you throw 100 times sometimes. Okay, so p of x equal to 0 is also included. Okay, and also remember children, nc0 and ncn both are equal to 1. Please remember this. Okay, ncn is not a problem. Even if you do, the answer will come. When nc0 comes, students gets confused because 0 is there. So when they say 0 factorial and divided by 0 comes, they get confused. So remember, nc0 is 1 because 0 factorial is taken for granted as 1. It is not 0. Okay, hope up to this is clear for you. We'll do problems in the next video. Thank you.